Hello, Mr. Collier here. This is part 3 of the Loop Track Lab, in which we're going to talk about the analysis, crunching the numbers for the loop track. You'll recall that in this lab we dropped the marble from different heights trying to get it to go successfully through the loop. What we were looking for was the minimum release height for it to successfully go through the loop. Then we're going to compare that minimum release height to the height of the top of the loop and see how they compare. Theoretically, you should be able to drop it from whatever that height is, and since energy is not created or destroyed, it would go all the way through the loop and come back. But in reality, there's friction on the ramp, so you have to drop it from a slightly higher height. That's what we're looking at in this lab, what the difference is between those heights. So I'm going to do the analysis here based on the data from the part 2 video. So go back and watch that if you want to get all the numbers. So we found that the mass of the steel marble was 0.02824 kilograms. In other words, it was 28 grams. And the minimum release height was 0.387 meters. In other words, 38 centimeters. And the height at the top of the loop was 0.306 meters, or 30.6 centimeters. Now we can determine the potential energy at that minimum release height, which is mass times gravity times height. So the mass is 0.02824, gravity is 9.8, and the height is 0.387. Multiply those, and you get the energy of 0.107 joules. We can also calculate the potential energy at the top of the loop using that height. To do that, we're really just swapping out this last height here for the height at the top of the loop, which gives us a potential energy of 0.0846. Now we're going to subtract the potential energy at the minimum release height minus the potential energy at the top of the loop, and we'll get 0.0224 joules of energy was lost. To calculate the percent lost, you're going to take the energy lost, 0.0224, and divide it by that minimum release height energy. And you find that 20% of the energy was lost. And that makes sense. There's friction between the marble and the track, which means that some energy is lost, and so you have to drop it from a higher height than you actually want it to go. In the conclusions, you're going to think about why energy was lost, how that relates to the law of conservation of energy, what might have happened if energy hadn't been lost, and how the two different marbles compared. And that's it. Good luck.